Okay, so we're going to evaluate some logarithms, which you've done before, but we're talking about two specific types of bases today. Regular old logarithm like this, you go, hey, 4 to what power gets me 64? And then think 4 to the third is 64. So that logarithm is just equal to 3. Two special kinds of logarithms that show up a lot and are used for other things are the common logarithm, which is log base 10. If you see a log without a base written, it's base 10. Also, natural log is ln of x, and that is a log with a base of e. So let's do a couple of different problems here. So pH of a substance is an equation that is negative log of your hydronium concentration of ions. So if I want the pH of this grapefruit, I'm going to plug in my ion concentration. And then your calculator will do log base 10. It's just the regular plain old log button. So if you plug in your 6.3 times 10 to the negative fourth power, making sure you use lots of parentheses and all that, you should get approximately 3.2 for your pH. We're going to go the other way. Soda has a pH of 2.7, and we want the concentration of hydronium ions. So first thing, let's get that logarithm by itself. So let's divide both sides by -1, which will give you -2.7. And then if you use what you already know to switch this back into exponential form, we could say that 10 to the -2.7 power equals our concentration of ions that we're trying to find. And then if you just do 10 to the -2.7 power, you're going to get approximately 0.002, or they like to do scientific notation for these, so 2.0 times 10 to the -3rd. Either is fine. We're going to look at one more involving sound. So you can measure sound in decibels using the formula that's up there, where I is the basically intensity of the sound you're interested in finding the decibel level of, and it's based on this unit factor of I sub 0. So if we plug in our conversation's intensity of I sub 0, the I sub 0s are going to divide out in our equation, which means you just have 10 times log of 500, which I forgot to multiply by 10, hang on. 10 times log of 500, which that's log base 10. You can type 10 times log of 500 in a calculator, and you get approximately 26.99 decibels. Now we're going to use the property that exponentials and logarithms are inverses if they have the same base. We're supposed to evaluate g of natural log of 5 squared, where we're plugging our function into e to the x power. So if we plug in natural log of 5 squared, which is really just log base e of 5 squared, we're raising e to the power that it takes to get 5 squared. Those are inverses if they are same base on your exponential and your log, so they kind of just undo each other, and you end up with your exponent of 5 squared, or 25. So exponential functions and logarithms being inverses is kind of helpful. Same idea here. We're plugging in natural log of 1 over e, and then since we have e raised to the power that it takes to get 1 over e, we're going to get 1 over e. Inverses, they undo. You can flip it around the other way. This time our function that we're plugging things into is natural log. So if we're plugging e to the 5th in our natural log function, we could go, those just undo each other since they're log base e, and you get 5. You could also use your properties of logarithms, like bring that exponent of 5 out in front, and then go, oh, natural log of e is just 1, because e to the 1st is e, and you get 5. Either way is fine. Same idea here, it's just you're plugging in a messier value. So you're doing natural log of e to the 2 natural log 3 power. The base is gonna be the same as your natural logarithm. You could bring 2 natural log 3 out in front and multiply by it if you want to, and you would just end up with 2 natural log of 3 times 1, because e raised to the first gets you e. One last thing we're going to look at is what's called change of base formula. So let's say that you want to do log base 2 of 9. Well, if you think about it, that's looking for 2 to what power gets you 9, but 2 to the second's 4, 2 to the third's 8, 2 to the fourth is 16, so it's not a whole number. It's somewhere between 3 and 4, but we really don't want to guess and check a whole bunch of decimals until we find a power to use. So we can use this thing called change of base formula. It says I can do log of 9 divided by log of 2, where it was basically log of my inside divided by log of my original base, because my calculator will do log base 10 or natural log. So if I want to approximate this one, I could do log base 10 of 8 divided by log base 10 of 5. We could kind of guess what it's going to be. Well, 5 to the first is 5, 5 to the second is 25, so it should be somewhere between 1 and 2. So if I pop up a calculator over here, key is to make sure that you close your parentheses when you type these in. So I'm going to do log of 8, close parentheses, divided by log of 5. And you end up with approximately 1.292. So 5 to the 1.292 power should get you 8. Exact same thing, we could do log base 10 of 0.1 divided by log base 10 of 2. You could also do natural log on these if you want. So you'd have log of 0.1 divided by log of 2. And you should get, approximately negative 3.322.